Okay, take two. It's so annoying when you're making these videos and you're like 9 minutes in and then they make an announcement over the loudspeaker or something. I have to make these videos at school because my internet is out at home. So many issues we're having today. So, lesson 3.3, we are proving that lines are parallel. So we have some warm-up exercises. For number 1, find the value of x. Okay, I can tell that I'm told that these lines are parallel. So x plus 20 is going to equal 52, which means that x is equal to 32. And write the converse of the following statement. If it is raining, then Josh needs an umbrella. The converse of that would be, if Josh needs an umbrella, then it is raining. Reset that page. So today we're going to learn a new postulate. It's postulate 16. It's the corresponding angles converse. And I talked about this yesterday in class that we were going to have converses today. So yesterday we learned that if two parallel lines are cut by a transversal, their corresponding angles are congruent. Today we're told if we have two lines, notice they don't tell us the lines are parallel. But when the transversal cuts them, their corresponding angles are congruent, then they are parallel. So yesterday it was parallel lines made corresponding angles that were congruent. Today it's if we have corresponding angles that are congruent, then the lines are parallel. And we can use this to solve a problem. So for instance, they want to know what value of x will make m and n parallel. That means we need 3x plus 5 to equal 65. We subtract 5 from both sides, we divide by 3, and we find that when x is equal to 20, these two angles are congruent, which means that m is parallel to n. Okay, so the next guided practice, is there enough information in the diagram to conclude that m is parallel to n? Well, if this is 75 degrees, and if these are congruent, well, then this would, not even if these are congruent, this would have to be 75 also, because the corresponding angles would be congruent if these lines were parallel. So since 75 and 105 add up to 180, these numbers are the same, so these lines must be parallel, because the corresponding angles are congruent. You can read all that if you want. Okay, next page. Explain why the postulate 16 is the converse of postulate 15. We've talked about this in class. I think I talked about it in the video just a few minutes ago. The converse is when we switch the hypothesis and the conclusion. So postulate 15, the hypothesis in 15 became the conclusion in 16. Really, the conclusion in 15 became the hypothesis in 16. And that's how you write a converse. So we have 3 converse theorems today. I had said yesterday, talked about that in class, that we would learn them today. So yesterday we learned that if I have 2 parallel lines cut by transversal, the alternate interior angles would be congruent. Today we're learning that if I have 2 lines, just 2 lines, but cut by a transversal, but I find that the alternate interior angles are congruent, then that means the lines must be parallel. Same thing with alternate exterior angles converse. If I find that I have 2 lines cut by a transversal and the alternate exterior angles are congruent, then the lines must be parallel. And the consecutive interior angle converse, if I find that I have consecutive interior angles that add up to whose sum adds up to 180 degrees that are supplementary, then by definition, by the converse, the lines must be parallel. So we're going to use them. In this example, you can freeze this and read the whole problem. But basically, I have 2 lines. I have a transversal, And the diagram shows me that this is congruent to that. That means that these lines must be parallel because the alternate interior angles are congruent. So that's the alternate interior angles converse theorem. Okay? So you can read this. Oh, I didn't reset it, but basically, yes, because the alternate exterior angles are congruent, that's what those markings say, the lines must be parallel. Okay, lines here must be parallel because of the corresponding angles converse. These lines are not necessarily parallel. Could be, could not be drawn to scale, but they may not be because 1 and 2 need to be congruent. They're alternate interior angles. When they're talking about the measure of angle 1 plus the measure of angle 2 equals 180 degrees, they're talking about consecutive interior angles, and that would look like that. But since that's not what they asked, the answer is no, you cannot prove it. Yeah. So, I'm going to look at the next page here to go through this. You can try to write the proof and follow along. But basically, here's the situation. We're told that angle 4 is congruent to angle 5. Angle 1 is congruent to angle 4. We know that because of vertical angles congruence theorem. So, if we're told 4 is congruent to 5, and 4 is also congruent to 1, then 1 has to be congruent to 5 from the transitive property of congruence. And since 1 and 5 are corresponding, if the corresponding angles are congruent, then the corresponding angles converse postulate would have to be proven, would be proven. So they talk now about a paragraph proof. Paragraph proof is basically just writing it in a paragraph form, and we're going to talk about that. I still want you to do 2-column proofs, but in the figure, we're told that R is parallel to S, so I want to mark that. Okay, and 1 is congruent to 3. They want to prove that P is congruent to 2. So the diagram is suggesting that you look at angles 1, 2, and 3. And it's also telling you may find it helpful to focus on one pair of lines at a time. Okay? So I'm kind of thinking, we're going to look in a minute how the book does it, but I'm kind of thinking that if these lines are parallel, okay, then I'm just going to put here what's equal to 3. So that would be equal to 3, and that would be equal to 3. Oh, and they told me 1 is congruent. So that's equal to 3, right? So let's look at what the book suggests here. So they tell you to look at 1 and 2, and then look at 2 and 3. We were looking at 3 and 1, okay? But they want us to look at 1 and 2 and 2 and 3. Angle 1 is congruent to angle 2 because R is parallel to S. They're corresponding. And 2 is congruent to 3, okay? So if 2 is congruent to 3, then we know that P is going to be equal to Q. Well, they told us that 1 was congruent to 3. So if 1 is congruent to 3, I'm just thinking here, okay? And 1 is congruent to 2. Since 1 is congruent to both of them, 3 is congruent to 2 because of the transitive property. So let's look at what they wrote here. Oh, they didn't give us the steps. Okay? Oh, this got pushed in there. We'll move that. So, okay, so this is a paragraph proof. Is given that R is parallel to S. That's the given. Okay? So, by the corresponding angle postulate, angle 1 is congruent. Hello.